So one of the things he said there caught my attention at the end, which was he said Sean's gonna give you a bit of a tour of like features of JavaFX. I thought of when Mike first asked me what can you show, how can you introduce JavaFX to these folks? I thought, well, I don't want to do an introduction type thing because that's what Stack Overflow is for. Okay, that's what books are for, and frankly, I'm not a teacher. I want to caveat that right away. I am not a teacher. I just try to be as creative as I can be, and I've accumulated some good and some bad habits that have proven to be advantageous with JavaFX, and I'd like to share them with you. And so then I thought, okay, well, how am I going to present this? And I thought, well, I'm not going to make a lesson plan. That would be a disaster. But I do have a whole bunch of code. And I realized that just going through those, there's a whole bunch of tricks that I've learned that I think really could be genericized for any user interface written in JavaFX, or any user interface really, that is graphically oriented, that's data oriented. So what I tried to do was cherry pick a bunch of the ideas that I could actually show you literally on screen, and then show you the code and say, and this is how you do it. See, it's not that bad. So we're going to cover things like animation, we're going to cover things like binding to properties, but we're not going to be covering, here's how you do a bind. No. Again, Stack Overflow. I'm going to show you, here's what I did with binding, and it created this. I hope you like it, and this is what it looks like. And so I hope this is, I wouldn't call this an advanced map of JavaFX. I would call this is 3 to 4 years of somebody who used to be a Java Swing developer and who learned JavaFX because he knew he had to, and is now going to share what I learned since then with you. All under the vein of deep space interplanetary trajectory design. Okay, so first things first, I am a contractor. I do not work for NASA. I do not represent NASA. My ideas that I share are my ideas. They represent how I feel about the language and the technology. Some of the software that you're going to see is used by NASA people, primarily at the Johnson Space Center on the upcoming Orion mission, which is the US's return to human spaceflight. And also, just recently, was purchased and is starting to be used over here at Goddard for a mission called IceCube. It's where we launch rappers from the 80s into space. Rappers, like there's like a couple people like kind of smile. I thought it was funny. It's not funny at all. It's terrible. It's terrible, YouTube. The audience laugh track's muted, I assure you. So IceCube is a CubeSat that's being launched to lunar orbit, and it's got water ice measuring sensor equipment on board. But in order for it to work, it needs to get really close to the surface of the moon. That is a very hard thing to do, believe it or not, especially for a CubeSat which doesn't have propulsion. So how do you get something that is this big, or maybe this big actually, because it's like a 2U type thing, so close that instruments on board something that small with such a limited power budget can do what it needs to do without crashing? That's a hard problem to solve. My software does that, amongst other things. Okay, but first, AI solutions.
How close is it really close?
Well, it depends on the scenario. So with some of the examples you see, which are kind of focused more on the moon Enceladus in Europa. Enceladus is a water ice moon of Saturn, and Europa is a water ice moon of Jupiter. We have to get under 250 kilometers during our passes in order to have a chance at the water plumes that shoot. So it's not a matter of getting close to the surface. It's a matter of getting close, not hitting, obviously, and then coming back around and doing it again. But you can't just do that with a perfect circle, like that really good late 90s, early 2000s band, because that's not how orbital mechanics work. I mean, when you have a perfect circle, it's because, and there's no such thing in orbital mechanics, it's because you're centered on the planetoid. But in order to get really close, you have to be offset, like an ellipse, okay? But that inherently adds a lot of chaos to your trajectory simply because of the energy involved. You're kind of getting really close, and you're going super fast and slingshotting back around up, and then hanging, and then coming back. And you're doing that, and you're kiltering a little bit around each time. I can show you that. With the Ice Cube mission, I can't remember the exact distances, but they have similar requirements. Instead of passing through plumes, what they want to do is they need a highly elliptical orbit, that's elliptical, but also highly inclined on the poles so that they can look down into the craters on the moon. The water ice on the moon is inside the craters, but it's specifically on the shadow side of these craters. So you can't, it's not enough to just pass over it. You have to have a really good angle in order to really, really scan these things. At least that's what I'm told. Oh, I'm a developer. I'm not a scientist. So like, this is what they tell me needs to be done, and I just write a whole bunch of code. Any other questions? I'm sure there will be. If anybody has a question, just raise your hand, do this, and I'll call you as soon as I shut up. And if anybody wants to see something in particular, if I have it, I'll show it. I promise.
What's the time frame for them gathering that data?
For Ice Cube? I do not know that answer yet. I'm sorry. I mean, the time frame, they're going to launch Ice Cube in 2018 tentatively with the first Orion mission launch, which everybody feels will probably get delayed by 6 months to a year. Who knows? I mean, I don't want to say that, but Orion will be the unmanned test of the the first launch will be the unmanned test of the Orion system, which will be the manned habitats, deep space manned habitat system. So on board, they're going to stuff like 20 CubeSats. And then once they get to Earth lunar orbit, what they call libration orbit, they're going to disperse these things. They're going to pop them off. And then this one in particular is heading towards this lunar orbit. There are other lunar CubeSats. There's other CubeSats that are going to be popped off, and they're going to drift down into Earth orbits. There's what they call halo orbits that live in between the Earth and the Moon. We'll get to that. Okay, good. So just a couple boilerplate slides, but this is my company. Okay, so I work here in Atlanta. I live in Bowie, and then we're down in Dahlgren. We just actually got some a small contract awarded to us over here at the Dahlgren base. So we have 5 or 6 job openings right now. So I'm taking resumes, you know, from anybody, whether they're a developer, electrical engineer, material engineers. We're looking for these people, quality types, management. We're hiring. We're hiring big time right now. So please come see me if you or you know anybody. Okay, and we do lots of stuff. We do custom commercial software. We launch the things. We track the things. We crash the things. We do it. Okay, so here's some. We do a lot. All these things. There's lots of contracts. People who are contractors, they get warm and fuzzy when they see this. This just means that we do a lot of the important stuff. Okay. Let's talk about JavaFX. Okay, so yes, I'm a recovering Swing developer. I'm old enough to remember Swing. I'm old enough to remember when Swing came out, and I thought, my God, this is amazing. And then 10 years on, nothing really had changed. And I thought, boy, it's not as shiny as it used to be. I wish somebody would fix this, and they did. They actually, I remember I was at Java 1 in 2008. It was my first time. And I remember sitting I was like in the keynote address. It was like 15th row. I was really close to the front. I was so excited because they had Neil Young come out. He actually was one of the keynote speakers, believe it or not, and I love Neil Young. And then one of the chief designers had come out, and they had just announced JavaFX. But they called it FX script because it was going to replace JavaScript and Swing. And people were like, what? And they were like, yeah, look at this. And then they pull up, and there's this live thing. They rolled out this huge desktop PC. and like they put it up on the thing, and it was a web page, and it was like some sort of like cutesy little like, it wasn't 3D graphics, it was like some sort of 2D thing where things were animating around and whatnot, and it looked like an applet, and people were like, oh yeah, applet, okay, great. And he goes, no, it's not an applet, this is FX script. And he shows us a script, and it's like this HTML JavaScript thing, but looks like Java, and it's got all these new Swingish type things, but better. And then he does this thing where he goes with the mouse and he clicks and he drags it over to the desktop and drops it on the desktop from the web page. And there's this like little a spinner that shows it's downloading thing. And he goes and bam, I now have a Java desktop application. And everyone was like, whoa! And then literally 10 seconds later, it like blue screened. And he was so mad because it was the keynote address, the keynote. And all these engineers at the time, Sun, come flying out from behind. They're like, ah! They're like fighting each other, trying to work on the keys. And yeah, that didn't work out so well. Then Oracle bought Sun, and they were like, this is nonsense. We don't do innovation. We just take money. And FX script lingered as like this technology that was in the bag. It worked, but they weren't developing it. And so then Swing got this like breath of fresh. It like came back to life as like still the standard, because there was no replacement. And it wasn't until JavaFX 2.0, which was released as part of the JDK 7, I think U12. So we're talking 2012 timeframe. Did it become like JavaFX 2.0, the replacement for Swing? It's tons of bugs, but a lot of potential. Show of hands, who here has used JavaFX? So we're about 2/3. Okay, who here has used Swing? Okay, so most people have. For the Swing developers in the room who haven't used JavaFX, I didn't cross-reference, you're gonna love it. But you gotta understand that like you can do things the old Swing way still. You're welcome to. You're doing it the hard way. There's way easier things you can do. Properties, bindings, all the built-in animations, the opacity. These are things that have become 1 and 2 lines of code now, where it was a half a page of code before. Trust me. Okay.
So there was some stuff with WPF with bindings. There was a pattern called MVVM. Do you know what I'm talking about?
Model view model. I gotta be honest. Well, what's your question actually?
So is this sort of like repeating that kind of stuff?
No. Well, because it exists before that term. I remember that term being tossed around. If you want to know what JavaFX is from a philosophical standpoint, it's we want to make things easy like Swing made things easy, but we don't want to do it from an ancestor hierarchy type frame setup like what Swing did, because it forced you into these narrow channels, and the code becomes very brittle if you try to alter it later, like much later. Now they're doing everything from a hardware accelerated scene graph standpoint. Everything is a node on a scene graph, meaning literally a gigantic memory graph, and it determines on the fly if that thing is able to be rendered or not, and it performs actual transforms on those nodes just like a 3D graphics engine. So it's got all those like performance bells and whistles, but you got to think like that in order to take advantage of those things. But then other than that, they present it to the user from an API standpoint as a traditional windowing toolkit. This was a compromise that they made in order to bridge the gap between the previous generation, which was Swing, to the developers, to the new. So we get the performance, but we get the comfort. That's a compromise. I kind of feel like they should have gone all out and just gone all the way in. But so I don't really think, to answer your question, I don't really think it's an MVVM type setup. If you want to implement that from your own philosophical standpoint, go right ahead. They do not enforce that in JavaFX. You can get yourself into all kinds of trouble in JavaFX in terms of like hard couplings and tight couplings and things like that if you really wanted to, but you shouldn't. Don't do that. Now, here's what I'd like to try to cover today. We're kind of already 25 minutes into the time slot, so I don't know if we're going to get into all this. And I did you all a favor, and I bolded all the actual concepts that are part of JavaFX that aren't my ramblings. Okay? So if you look at this for a second, if you have any experience with JavaFX, you're kind of look at it and say, well, okay, that might be some of these might be a little advanced. Some of these things up here, it's like, what's the big deal? Totally, I get it. I'm going to show you some cute and tricky usages of these things to help drive the point across, okay? If you want to learn for the first time how to do layouts or how to do custom nodes or whatever, now's not the time. I'm not going to be able to show it to you. I'm willing to answer your questions after. What you need is a good book called JavaFX by Example, which I wrote like one chapter for. So like it's kind of a shameless plug, but it's an excellent book that will literally take you from start to finish from I know nothing about JavaFX to I can now write JavaFX that runs on embedded devices. Okay, so we'll start in the first one. So layouts. There's tons of layouts. Grid pane, box, or VBox, HBox. They still have border panes. Okay, use them. Use the right one for the job. But remember this: layouts are there to make it easy for you to do things and not get into all kinds of trouble. okay? But the really cool stuff is where you get yourself into trouble, okay? And how do you get into trouble? When you start custom laying out your subcomponents, when you start laying things out based on screen resolution, when you start stacking things on top of each other, that's where it gets interesting. So how do you do that? You do that with stack panes. So a stack pane is a pane which has all the default settings so that when you add it to the scene, by default, it goes right into the center, okay? And then you can reposition it later. But then the order that you add things to that stack pane and the order that you add stack panes to your base container is maintained, and it allows you to overlap things. So, okay. The first thing you might say is, okay, I get it. I can overlap things. But there's some amazing things you can do by stacking panes on top of each other and then hiding them arbitrarily based on the current settings. HUD overlays, messaging, things like that normally you would have to dedicate a region of the screen and say, okay, it's always going to be here, and now you've lost that 2 inches of that screen. You can have it on the screen in a spot that you want it to be, just invisible. And then when some property changes, and we're going to get to that, properties and bindings, it just becomes visible. The obvious application are like heads-up display type things, warnings, messages, things like that. But I do it like a card layout. The old school Swing developers might remember card layout, where I'll have like different types of 2D tools and 3D tools all put on top of each other. And then based on what they select in the menu or what they do on the screen, and I'm not moving things around. I'm just saying, okay, you're visible. Now you're visible, you're not. Like, that's it. It's a little bit of maintenance at the main application level, you know, but it's really just event handling. If this event occurred or this property changed, do this. It's really not that hard. And what they say when it comes to layouts is each one of these panes has a layout children method. That's defined under the hood, like under the hood. Like wherever the hood is, it's underneath the hood of what's underneath that. And you don't ever want to mess with that. Except that's where all the fun stuff is. And that's exactly what I do, and I'm going to show you how to do that right now, okay? So the first thing they'll tell you in JavaFX school or any GUI school is don't mess with layout children, because those are where the rules of a given layout are enforced. And the first thing I'm going to tell you to do is, yeah, just do it. Totally do it. So let's see here. Okay. This will be so frowned upon by so many people, I suspect. Okay, so I have this thing called a periapsis map. A periapsis is a type of data point associated with trajectories. Some trajectories have one, some have many. And it's really useful to see these in 2D. Up on the screen, all flattened out, so that the z-axis, aka the altitude, is flattened. And they do that, I should probably actually just show you. They do that because there are patterns and shapes in these maps, which make a whole lot of sense to the trajectory designers and the scientists. I'm just gonna run the actual application. I should have started that up ahead of time. I apologize.
You might have to share or duplicate the screens.
Here we go. Boom. Okay. Do me a favor. This is optimized for 1080p, and this screen right here is 720. So I can get the point across, but you might want to look over here. Can we kill these lights?
Yeah.
Is that possible?
Yeah.
Because I have a dark motif, and there's a reason for that, actually. And that gives me a chance to...
That's nice.
We had this exact same conversation last time, I remember.
Yes. We still don't know how to do it. But we know that it's one of the...
Or you guys both trying to do it at the same time? Yeah. I clicked it and went down and automatically went up.
Andy's over here doing it too.
This is the master control.
Okay.
Well, that's better than before. I'll take that. I want to make sure that the color isn't washed out. So, okay. So notice this map here. Oh, that's right. My file browsing thing isn't on the screen. There we go. This is a 20 megabyte map file. I'm just going to drag and drop it. Pay attention over here if you can. Okay, lots of color. Okay. So first and foremost, what you're seeing is a periapsis map, and nice. And this is a canvas object, and we're going to cover that later. And what you're actually looking at is an application with about 8 different stack panes, okay, all these different tools and whatnot, of which only one is currently visible, okay, and it's the default one, to be fair. And we can switch that without a problem. A little washed out here. This is a better view. We can switch, okay? And it's still all there, okay? The code is super simple. But in order to make this work, I had to override the layout children. I had to say, okay, I have to size my canvas object to be the size of the screen. I had to position it and center it myself and all that. And it gets a little ornery, you know? So, but it's not hard. Once you've done it a few times, it's just not that hard. So I'm in NetBeans right now. NetBeans is my IDE of choice. I love NetBeans. This doesn't matter if you want to use Eclipse or IntelliJ. JavaFX works just the same in those tools. So this class is, okay, well, I have a custom interface called MapView, which enforces a few things, but under the hood, it's a stack pane. Trust me. So then I have my layout children, and I have to go and get, see this right here, the snap. Oh, geez, sorry guys, I keep forgetting that. I'm so sorry.
You can duplicate your screens if you want to just have an upload.
I might do that. I don't know. Well, here, let me start this. So this is my layout children method, and I have to first define. Okay, where are my ranges of my total screen? I've got a spinner in here. I've got labels that I've got that are laid out there, and I've got to like set all these layouts here. You don't want to do this generally if you can avoid it. But in order to get the fancy stuff, you kind of have to do it. But it's really not that hard. And all my layout children calls where I override them myself, they all look the same. Okay? I check to see if I'm allowing resizing or if I'm fixing it. Because of the amount of data involved, sometimes I want to allow data things to change rapidly, and I don't want to redraw it every single time. So I have little checks like that. I have different ways to draw these things. And then when it really comes down to it, in the end, it becomes a single call. Draw a map by group. We're going to cover this in a little bit. And that's it. This gets called every time the system believes that stack pane needs to be redrawn, which, by the way, all this is filtering through all these data points to see what's visible, what's not, and then drawing them on a canvas. I'm going to get to that in a second. No, about an hour. Okay, so any questions? I know that was like right through it, right? Like, the point wasn't to make you experts on layouts and stack panes. The point was that this is one approach that you can take. So investigate it. Okay, it works. Does anybody have any questions about stack panes and like what I just whizzed through super fast? I didn't think so. There wasn't enough content for you to even question, really. I just realized. Let's go to the next one. Okay, custom components. What does he mean by that? There's two types of custom components. There's, I'm going to write the code that actually draws out a new component. I want a component that looks like a lever, like this. I can't think of one off the top of my head. That's not what I'm talking about here. That's hard, and it's very unsatisfying because everybody has complaints and nobody actually thanks you for that type of work. Trust me. What I'm talking about is take existing smaller components like a button or a drop down or that type of thing and combine them into one mega component, a custom component, and then wrap it all into a single class so that it handles all the layout itself, handles all its own events, and then you can add it to your application. This is a really good way to encapsulate functionality. Okay? Yeah, that's what I wrote actually. That's kind of nice I said that. But also, it becomes a sort of like a way to manage state. And what I mean by state is like, if you want to associate some data or some sort of current state versus a set of states that you know it could be in, it's not trivial to manage it like that. So don't be afraid to create this like fake node and then add your nodes and do all your layout in it. But please, if you're going to do that, keep it simple. Keep your layout simple. Don't make these grandiose layouts with lots of custom things in there. You're overkill. You're over-engineering it. Keep small things so it's more reusable. So I did this with a couple things. I got this tool called, I'm atrocious at names. I have this tool called a slider box. Oh, it's going to kill me because of the thing. See if I can do it from over there. Okay, so, oh no. Okay, so the problem that we're experiencing is that the resolution's at 720 and it's optimized for 1080 and it doesn't downsize well because some of these things have fixed widths. I might not be able to show you that particular one.
Can you shift the screen over a little bit? Or the window over?
Yeah, why not, right? Oh, good idea, man. I can show you. Okay, so I had this idea that if we had data and we wanted to filter it, we could do so manually or visually. And so I said, okay, how am I going to do that? I don't want to like make like a drop-down box and then have like a spinner for the minimum and the spinner for the maximum and have people like change them and then, oh, okay, well, let me change a different variable, and then they'd use the drop-down box. Because why? Because you lose sight of what you're doing. I wanted some set of controls that would visually show you what the current bounds were for each variable. Well, the only way to really do that is to have separate controls, and that meant it needed to be reusable. So I wanted to be able to, and keep your eye on this, on the data, I wanted to be able to grab one of these things and have it filter the data dynamically. Look at that. What is this? What is this little snowflake in here? I don't know. I'm not a scientist. But I can tell you one thing. It's useful because it's under there, but you would have never seen it if we hadn't filtered on the trajectory order, which is ordered by cardinality. We might want to filter the minimum z position. Look at that. We got two different families in there. And why is that important? Well, for this particular application, you see here. Mode, point selection. Okay, so looking here on the screen, those trajectories are not the same as those trajectories. It's pretty damn obvious, right? Now, the whole point of this tool is to present these overwhelming amounts of data along with the different controls that you see on the right in order to filter that down rapidly. So that these scientists that really know a lot about these systems, but they can't possibly memorize all the data because it's nearly infinite in its combinatorics, they can pull open a slice of data, which represents maybe the energy of the spacecraft at a moment in time, and say, what are my options? Well, I need to look at the whole thing to know where I'm at, but I need to very quickly whittle it down so I can find the needles in the haystack. And that's the point of this tool. So what does that look like? What does this slider box look like? It looks like this. Where are we? Is this the code? Yes, that is the code. Okay. Slider box. Boom. Yeah, this is our code. You can't have it. It's just a VBox. And then inside of it, I've defined some buttons, a range slider. Okay, so a range slider is a custom component that was actually written by Dr. Jose Pareda. Excellent dude. He's a beast at this stuff. He's from Spain. And he took the base slider in JavaFX and said, no, we need to be able to define ranges. And he added another thing and then updated all the event handling to handle both a min and a max and not just current value. So that's an example of a custom node that you're literally drawing a whole new component. He had to write code that drew out from point to point to point, like a CAD tool, everything you saw on the screen. And then as a user's mouse passed over certain pixels, react to it. Very complicated, a lot going on there. I don't want to do that. He did. He even says it wasn't worth his time. So when you make these custom tools, focus on HBoxes and VBoxes. Keeps it real simple. But make sure that you add properties to your component so that whenever it changes, people in the world can listen to it and see the change. They don't have to have direct access to the component itself. Okay? This is good for obvious encapsulation reasons, but it's also good because you're using properties to bind to, and we're going to cover binding next. Okay? So in other words, when you bind to a property, when something changes, you automatically change. One line of code. I'll get to that in a second. For those of you who haven't used properties, I've got doubles for like the min and the max of the slider. Also what the current low and what the current high is, because remember it's a range slider, so we have a min, a low, and a high. But we also have a minimum and a maximum, so these are two different values. They can change, and I made it so they can change dynamically. And then I've got different set theory type Boolean logic type things like, do you want to turn this thing off? Do you want it to be an exclusive range, an inclusive, the inverse? I'm sure there's 1,000 different combinations that I could have added to that. And then I was going to add like an icon, and I got lazy and I just didn't do it. Okay, so that's it. Okay, the rest is just laying the thing out. That's it. Here's an example of binding. This is a super simple but very common thing. What happens if you have a button that like disables something? That's a common thing in a GUI. And you want a whole bunch of things to automatically disable. So in JavaFX, using properties, you would take the property, in this case the disable property, of a particular item. And I mean, this is it. You simply bind it to a property of something that you want to watch. So in my case, I created an off toggle button. And whenever they hit that button, I want all these things to disable. It's a line of code. Now, if you were pre-JavaFX and you want to do something like this, you would have to add a new event listener to the toggle button. And then you would have to check the current state of the toggle button. And then you'd have to say, well, oh, it's false, so I need to go, and then you'd have to have a list of all these things, and then each one set. And then you'd have to have another, I mean, you see where I'm going? Like, yeah, you could do it before, but the code looked like this. Now it's just line. So it's sustainable. And the other cool part is you can do all kinds of stuff. I mean, it doesn't have to be the disable property. If, like let's say you hit that button, there's all kinds of other properties. See, I don't even know what half these things are. I don't even want to know. You can change the background color based on something if you want. There's stuff. You get what I'm saying. And so they have these property types, like a disable property is like a kind of like a true-false type property. They also have like that background property. I don't remember off the top of my head, but it's probably a color property. So whatever the color is, this other one automatically becomes it. It's like a hard coupling, but without the wires. So the next slide talks about that actually. So I just kind of showed you one example of binding, and I'm going to show you a couple other ones, some cool stuff. We're finally going to start getting into more spacey stuff. But I kind of described the old way to do it, But why would you want to stick? Why do they even have that in there then? Well, because let's face it, some things can't be done in one line of code, right? So how do you know what the difference is? Well, if you have custom logic that has to be implemented, you should be doing it in using a listener. But it doesn't have to be embarrassingly long or agitating. You can have it be kind of like a one-liner. I'm going to run a separate application here. I'm going to keep the other one up. Where am I? Got to find the mouse. There we go. Okay. Tested it this morning. Should work. What? Oh, it's still trying to run the old one. Okay, that's fine.
You got a saturating project there.
Yeah. I got the terrain map thing. Let's see. I'll just run it the old way. Let me pull over here so I can do some maintenance here. Terrain demo. I thought I did that. I'll be up in about 10 more seconds here. So I created this demo because one of the things that we have to do. There it is. Okay, great. One of the things we have to do is not now, but it's kind of like the next thing. Is an analyze based on where our trajectory is. 3D. The planet. Okay, we're here, and they want us to actually take a spacecraft and fly it in between the canyons of the ice on Enceladus. When the chief trajectory designer asked me if I could do that, I was like, hell yeah! And I'm thinking, what the hell? I didn't know what that's. Are you guys insane? Here's the. So I made this little demo. We have to load terrain information, so it's a black screen on purpose. And all I'm going to do over here. Let's see. I'm going to take a terrain map of Enceladus. Okay, we'll look at the southern pole. So this is what it looks like. Oh, sorry, wrong screen. I really should duplicate. Okay, it's been flattened to a 2D projection from the southern sphere. See all these features? Okay, we got to get that in the software. So I wrote this little diddly-do that lets you drag that into there. Bam. And then renders it a 3D surface map. So you can scan in on here, and you can look at one of these more ornery. I scaled down the resolution so it would load quickly, so you see the jaggedness. And this particular map is actually one of the lower res ones. See that crevice? What we need to do is not only analyze those from an altitude and an impact perspective, but we need to be able to show in 3D, like this is where your trajectory is, and we're going to alter the projection to be in 2D. And we're going to show, like at this point in the trajectory, you're 200 kilometers away from impact, so if you screw this up, your spacecraft's toast. That thing that cost $500 million and took like 5 years to get there, it's gone on your first pass because you didn't take into account X, Y, or Z. So that's the point of this, okay? So how did you do that, Sean? What was I even going to show? Oh, well, okay, so this is just a 3D surface plot. I take the data of the map and just draw a bunch of triangles. It's not that hard. I don't have time to show that to you. Mike is thinking maybe there'll be a JavaFX 3D session dedicated to that type of stuff later. I'd be happy to do that then in the future. But what I'd like to show you is the binding that was implemented for the camera lights. So moving the camera, let's see, I need to go to init lights. Init lights, there we go. So in 3D worlds, you have things called point lights. The light goes that way. And you have ambient light, which is all around you. And it affects all objects equally from all directions. So ambient lights generally are like amateur hour, like, you just got to light something up and see it real quick. But usually you need some amount of ambient light in order to keep things visible. And then usually you add point lights to add shadow, because it gives the illusion of 3D depth to the user viewing it. But you don't want to, it's kind of hard to just put point lights in different spots because you don't know where the camera's going to go, that sort of thing. So one common thing to do is to do a headlight, which is they take the light, they put it on the front of the camera, which is also a 3D node, and then as the camera moves through the 3D scene, the point light goes with it, right? Come on, liven up, people. I got my hand stuck to my head. Okay, but here's the problem. The point light is a node, and the camera is a node. So, oh, yeah, right. So if I move the camera, that doesn't mean the point light's going to move, right? And this is how you make that happen. With simple binds. It's really that simple. So if you have a point light that has like your lights will automatically have an XYZ coordinate, which has properties associated with it. And if your camera moves, it automatically moves. That's it. That's the point of properties and binding, is to do stuff like that. So you don't have to have some sort of code that's on a timer that's scanning and saying, oh, did it move? Did it move? I better move. The code becomes a nightmare. Back in the bad old days of 3D graphics and game programming, they had memory locations. And what you would do is you would have a render loop, and every so often that render loop would update, and it would just scan certain spots and just take those values and jam them into other spots and use those as the calculations for transforming these things around. They still do that because that's how you go really fast. But isn't it nice that something like JavaFX can give an API like this in the same packages as your 2D stuff? You're not going to make a 3D first-person shooter game that's like AAA studio style with JavaFX, but you are going to do stuff like what I just did. Okay? Useful things. Things that aren't buggy on day one, like every game since 1990 or 2010. Okay, so and there's some other examples of things that I commented out because I never got working. And the only thing I want to point out is that binding can go both ways. It can be one-directional or bidirectional. And bidirectional is exactly what it sounds like. It's if one changes, the other changes, and vice versa. That's kind of nice. It's like saving you an extra line of code. Caveat, you can only bind a property to one other property at a time. There cannot be any race conditions. The JavaFX will prevent you from doing that, okay? So I can't say bind this property to this property over here. Oh, and then on the next line, bind it again. It's going to be like, eh. It'll let you write the code, and then it'll crash runtime with a specific error that tells you exactly why you can't do that. Okay, so that's kind of fun. Going back to this, I think we skipped a slide. Yes, 2 slides. Whew. Okay, so I want to show you this one here, Billboard test, the create scene. Let's see. This is another example of binding, but this one's like a transform type thing, where we're binding like whenever the rotation of an object in 3D space changes, we automatically change something else. It's very similar. And I want to show you that because the next thing I want to show you is related to that same code, which is snapshot. So JavaFX lets you generate your GUIs completely independently from the screen. It's only a matter, it's an arbitrary matter that you chose to put it on the screen. It will render everything off screen. And if you want to film that, you can by using snapshot. Snapshot takes a screenshot, if you will, of a component or a group of components or an entire layout. And you can do that as many times as you want, as fast as you want, well, as fast as the JavaFX rendering system can handle. And then you can then take those images and store them on your shelf if you want, or you can put those images anywhere an image can be placed. Background texture, the side of a box, on a 3D object flying through space. Okay, we'll just go right to that. I was going to show you this 3D label thing. I made this. One of the problems with a 3D scene is how do you put text in a 3D scene? So you know, look, I'm a T, and you look at me in 3D, and then you rotate that camera over there, like I'm still. There's my normal, my perpendicular normal coming off my face. But you just rotated over there, and I'm this like enormous T in the middle of space, and I'm like really wafer thin, thinner than I've ever been in my life and never ever will be. And so it isn't real. It's like a gigantic floating piece of paper in space that's like super thin. What you really want is something that always rotates to face the camera, right? And you've seen these things. So how do you do that? That's what this was, where I created this tool. Let's pull it open. I've been talking about it. Might as well show you guys. Label 3D. Okay, so I created this class, which is an image view, because I just want to show the image. Okay, it implements a billboarding behavior. That's something that's custom, super custom. And all you do is you pass to it a text object. It renders the text object, so fonts, colors, sizes, anything you can do with the text object, which is quite a bit. It takes care of it all off screen. And then what I do is I use snapshot. Well, in this case, this is the actual class you do, snapshot parameters. And then I, with a little trickery here, setting things back transparent, that sort of thing, I then take a snapshot of the text object, take that image, and then add it to my 3D scene as an image object. And then I just simply rotate that object whenever the camera changes. Okay, and it looks like this. Yeah. Oh, can we close this now? You guys don't like this one. This one was boring. You didn't like it. Okay. Where is it? Bam. Label 3D, billboard behavior. I had a billboard test. There we go. Just run it real quick. Come on now. I know you can do it. Oh, it's over here. Huh. Bam. Okay, so what I wanted to do was create an object in 3D space, which was this text label, to represent points in a region of interest that were generally fixed. So for example, you're the Earth. He's the Earth, right? And there's the sun, clearly, because it's in my face. And here I'm the moon, right? There are points in orbital mechanical theory in real life that exist, which are essentially the equilibriums between these gravitational pulls. So if somebody had the guts to come up and help me out with it, they're not going to, or to stand like this close to me, they would fall into the moon's gravity. But if they were to be over here, they would fall into the Earth's gravity. The moon's in the Earth's gravity, of course. It's also in the sun's gravity, but it's mostly influenced by the Earth. But what happens if we're kind of in the middle? Well, which way does it go? Well, it's going to eventually fall one way or the other. But with just a little bit of nudging every so often, you can kind of go in these circles where you just kind of like do this. That's it. And you're literally in the middle of nowhere because you're at the equilibrium point. That's called a Lagrange point. Okay? And each three-bodied system, planet, moon, spacecraft, three-bodied, has 5 Lagrange points. One in between the two bodies, one on the far side of the smaller body, one on the far side of the larger body, and then 2 off to the sides that are really unstable. They're not really usable, but you can kind of coast through there and hang for a little bit. Okay? And so my tool specializes in getting you in and out of these really hard to get to, but once you're there, you're set for life type orbits. The James Webb Space Telescope is going to live at a Lagrange point, specifically Earth, Sun, L2. So, oh hell, let's make this a science lesson. That's me like 2 years ago. Looks like I'm, oh wait, where are we? There we go. That's me from like a couple years ago. Looks like I'm constipated. Okay, let's see here. Earth, Sun, Lagrange. Let's see what comes up. This could be interesting. Images. Here we go. Do I lose my job? Oh no, okay. Oh, good. This one's a good one. Where are we? Bam. You guys can see that, right? So this is what I mean by Earth, like the Lagrange points. These lines are kind of arbitrary, but they're called the zero velocity curves. I don't want to go in there. It took me 2 years to figure out what that even meant. But essentially, this is the direction in which your velocity falls. So you get in here, you're going to fall back to your smaller body. You get over here, you fall back to your bigger body. In this picture, our 3 bodies are the Earth, the Sun, and the spacecraft. But this can be like Saturn, Enceladus spacecraft. This can be Jupiter, Europa spacecraft. This can be Earth, Moon. Okay? And there's all kinds of equations that let you define all these things and then work within these constraints. That's what my software does. It captures those constraints and those equations. James Webb is going to live here. We're going to shoot out like this and then come in and then we're just going to hang out at L2. Okay? L1 already has spacecraft there, believe it or not. We have several. NASA, does the Air Force have any? The Air Force does not have any there that I know of. NOAA has one called Discover. These are typically good to either face the Earth or face the Sun at all times. Why would you do that? Because you want to measure precipitation, thermal activity on the Sun or on the Earth. You want to spy on your citizens, things like that. James Webb is going to L2 because it's trying to get as far away from the Sun as possible and the Earth to eliminate as much light interference as possible. We can't just send the damn thing out into the middle of nowhere. We can't just go over here somewhere because there's nothing there. So the velocity alone to get there, we could never stop. There's nowhere to park ourselves. So the only real place is over here because the Earth acts as a sort of shield, if you will, and we can do this circular thing which allows us to rotate what's called a sun shield towards wherever the Sun is at that moment. And when they say rotate, really all they're doing is they're rotating the attitude of the spacecraft itself. They're not shifting this enormous, gigantic shield. The shield is there. They're just rotating the whole spacecraft as one hard body, so to speak. They do that so that they're always faced into the inky blackness of space. And then when somebody is dumb enough to light up a firecracker in another solar system, we'll see it. And we'll go and get their oil, and then everybody will be happy. Okay. Oh, is that mine? No. Damn. Every so often I see pictures of like stuff that I did. I'm like, oh, I did that, and nobody cares. Okay, so I demonstrated oh, hey, you guys didn't actually see the actual behavior. Here, see how it stays in one spot now? I mean, there is some rotation when you go up and down. I didn't really get all the transforms perfect, but I mean, it's pretty close. It always stays flat instead of like the camera whizzing by it, you know? Zooming out, zooming out? Yeah, there you go. it gets smaller, so it stays in line, that sort of thing. If I go to the left, it tends to stay on the screen, but you want it to slide a little bit. So I had to play all these games that like, oh, I want it to move a little, but not a lot, and all that. So here's a more complex example. I hope you guys like this. Oh, let me kill some of these apps. Don't need you. Kill that. We'll kill the billboard test. Okay, great. So let's switch over to NetBeans. Here we are, NetBeans. Nice to see you again. We want to do the CubeSat media. Okay, let's see. So this is actually a separate project that I did. It's telling me that one of the project references is broken. That's interesting. This worked this morning. I actually did go through and check. Oh, ha. Tricky. So, yeah. So I created, so we had a holiday party on Christmas last year. And one of the upper managers goes, hey man, do something cool. Yeah, hold on. Here you go, look at that. So I thought, okay, what can I do? And I thought, well, I want to show off this tool that I've been developing. Right, Sean. There you go. In some way, here you go. Oh, see, it's off center. That's kind of weird. I'm gonna shift that over a bit. And so they said, and make it do something with touchscreens. I mean, they're literally just dictating these things to me, I'm like, okay. So look closely. Look at these cubes that are flying through space. It's just a little tiny Earth thing. Notice how the sides are changing? I created this thing for a touchscreen where it would pull open like 4 videos of this tool that we'd been developing, which it was still in its early phases back then. And we had all these customers that would come over to our holiday party and would schmooze them, and they would tour them through and be like, oh, well, you've had your 5th glass of wine, check this out, And so I had this big touchscreen where it would show the videos. These are MP4s of the tool that we recorded previously, and it's being wrapped around these 3D objects in a 3D scene. Okay, so it looks super fancy, and then when you click on this thing, bam, it just blows it up so you can see the whole thing, and it's off center because of the again, I didn't bother to write code that checked to see if you were less than 1080p, so it's expecting way more pixels off to the side, but you get the point. This is just images of the tool being used, that sort of thing. This is ground track coverage around Europa. Wicked boring stuff. You wouldn't care about finding life on other planets. So then you click this thing and it goes back, and then there's different videos. There's a video, it's playing, right? Yeah, there you go. Oh yeah, you can't see something. You get the point, right? Okay, great. So I'm gonna get rid of this so it's not distracting me. So how the heck did I get the video on the side of a 3D image, a 3D shape? Snapshot, the snapshot library, okay? So that's done. How is it done? CubeSat Media and Media Box. So I created this thing that's Media Box, which it's a 3D. It's a box, which is a shape 3D. Oh, sorry again. Okay, so see that it's a shape 3D object. So this comes out of the box, pun intended, from JavaFX. Okay, it's one of the few JavaFX 3D things they actually make. And then I extended it by saying, well, I'm going to have a media object. I'm going to have a media player that's going to play that media object. And then I'm going to create 2 different media views. I'm going to take a media view, which is the thing that's going to play in 3D around it. And then I'm going to have another media view that's like the full, thing that you see. Remember when I clicked on it and it was like, that's that second one. And then I'm not going to render this on screen. Totally off screen. It's going to do its thing off screen. So the media object is the movie. It's just an MP4. It's cool because you can have a local file, which is what I did here, or you can have a web address and just pull it down dynamically. It handles all that. It can be a MP4, it can be an audio file. There's an It's not exhaustive, but there's a significant list of formats that you can make work with that. You then need a media player. A media player is like the VCR of this part of this equation. So if you want to hit it, have it play, have it loop, have it rewind, have it do all that. That's what you need that control for. And then the media view is literally the on-screen component. Now, why do I have an on-screen component for something that I just got done seeing? I'm not going to render on screen. Well, it's because that's what creates the actual imagery. And the fact that I'm not blasting it onto the bits on the screen doesn't mean anything. I am, however, going to take snapshots of that, create a texture, and then every millisecond wrap that texture around the 3D object with a simple set texture map. There's like it's a singular call. I could show it to you, but it's totally unexcited. One line. And so all you need is an image, and then JavaFX 3D figures out the rest. It's, oh, I'm going to wrap this around this, and sometimes it looks awesome. Once in a while it looks a little goofy, but so then just every millisecond, like boop, 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 boop. The human brain, on average, without like major disabilities or heavy drug use, Ozzy Osbourne type, they respond to about 14 milliseconds. They have a 14 millisecond response time. Okay? And so that's why, in a way, there's some math involved with this, but that's why US TV standards tend to be around 24 frames per second, or 30 frames per second. That's about the speed at which you're getting twice as many frames as what a human being can perceive and react to. So it appears as though it's smooth animation. Okay? So in other words, if you want to render something and have it look like good and not total crap, what you need to do is you have to have all your rendering and all your processing done in less than 15-ish milliseconds. And the older you get, the more drug-addled you get, the bigger that number. Young people tend to be sub 10, actually. So that's why younger people are better at video games. That's the bottom line. That's just an interesting little. Please do not fact check me on any of that. I don't have any papers to reference, but that's mostly true. Now, what is happening in the background is I want to there we go. I've got this this timeline thing. I wanted to show you these things here. So JavaFX allows you to do animation, and that was actually going to be my next slide, and that's why I wanted to talk about the media box thing, because it naturally leads into animations. We do they have objects called timeline, the transition interface, which implemented in that they have fade transitions, scale transitions, rotate, etc., etc., etc. You define a timeline, and then you define a keyframe, which tells it how often to fire, and you tell it, it tells how often to reset itself. That's like the period of the timeline. And then this key value is in between 0 and the end of the period. This is what you want to change, and you want it to change this many times. That's like an interpolation. Now, there's all kinds of additional parameters you can use if you want to get more complicated, but essentially, these 3 lines of code basically say every 30 seconds, change the y and the x angle values by 1 degree from 0 to 360. So essentially, do like a rotation, and take 30 seconds to do that full rotation. Was there a question?
Every 30 seconds? Isn't this milliseconds?
Well, you can set milliseconds. This I wanted my delay to be more slow and gradual because I wanted the viewer to see the video playing and be like, oh wow, that's pretty cool, even though that has nothing to do with the actual tool. That's just like this little tech demo that we threw together. So in this case, I told it to use seconds. So this is a JavaFX thing right here. You can set, here. We could totally set it to milliseconds, but then it would be like hauling ass, and then it'd look like a blur and nobody would recognize it.
So that's not the update.
No, okay, so all this does is it updates the rotation of those boxes, okay? Okay, here's an animation timer. I call it the orbit timer. Why do I call it the orbit timer? Because I'm doing a really simplistic circle formula, and I'm translating the object itself around that circle. And I'm using a timer which is in milliseconds, actually, this animation timer. So in other words, I'm saying, using this formula, plug whatever the current milliseconds are in this timer object, and then just do a little math to figure out where on the circle arc you are, and just move yourself there. So essentially, I'm banking and guaranteeing that this will work. Given that a circle, there's a certain there's a formula you can use to figure out where your x and y coordinates are along the arc, and then you're just, as long as this keeps firing, it's going to keep moving to another location. But by the way, the formula uses that time as its number. So essentially, the number is always going up, so it's always going around. And then it gets back to 0 and it resets. But oh, by the way, we're back to 0 again. Just a little trick. And then there's some other tricks. Let's see. Okay, here's where we update the side right here. Another animation timer. Hey, why not? It works. And this time, we get the width and the height of the media view. Notice that variable. I take a snapshot of whatever it is at that moment. Bam, I take that snapshot. And then I create a 3D material out of it. Trust me, this is a JavaFX thing. They use something called Phong materials. Some guy named Phong invented this way to wrap textures around 3D shapes back in the 90s. And so, famous guy. So essentially, I'm creating a material, and then I just set the image of it. And actually, what I'm actually doing is getting a reference to the material that's currently on the object. So I'm not like creating new things. I'm throwing them on the heap and using all this memory. I waste memory in many other locations, but in this one, I did it right. So that's it.
Where do you specify the milliseconds, the time?
That's the default for animation timer.
Oh, okay.
So if you wanted something other than milliseconds, you either have to implement a custom animation timer, or you have to do some sort of voodoo black magic math that says, okay, whatever the current time is, I'll convert it to the number of seconds, and then let's see, how did I do that here? Yeah. Oh yeah. Okay. So what I did this little cheesy thing where I got the current number of milliseconds just by incrementing a permanent class variable. It's kind of cheating, but whatever, it works. Especially for a tech demo that I had 2 days to make work. So yeah. So yeah, I mean, you can make your own timer and then do whatever size that you want. Oh, don't forget to tell it to start. Sorry, I almost quit my job because I couldn't figure out why it wasn't working. There you go, and that's it. Basically, start and stop, and you can manually say, okay, do your voodoo right there. So like you could have a property that whenever it changes, using what's called an invalidation listener or a change listener. Oh, this thing changed, and because it changed, I need to manually force a render of my screen to keep up with it, just because. Okay? So in that sense, it's just an event handler, just like any other event handler you might use with a GUI, except that it's got the built-in smarts to think and do things along the time. I've got more stuff like that, and these things are kind of nice. When you start doing things with timelines, you can kind of do the same thing as an animation timer. I mean, there's the different ways to skin this cat, but then you get access to like the flow of time. So you can tell it to reverse or not reverse. You can listen to when it finishes. So you can say, hey, I want to fade out into oblivion, but when I'm gone, do this other thing. And then it does it. Oh, by the way, I created this fading opacity transition thing with the timeline thing. I was so proud of myself. And then I actually read the Java docs, and they have a fade transition object that does the exact same thing. Use the fade transition object, because I guarantee you, if you try to do things more complicated than this, you're going to have bugs, and it's hard to debug things that are happening in the background constantly at low levels of speed, because it's not like you can set a breakpoint. You have to just observe it and try to guess what's wrong, unfortunately. Okay, so let's go back to our presentation. Hey, no. Why is it not going back? Okay, so we've abused Snapshot, and people will think you're a genius for it. Wait, we covered the media player. Great. Okay, make a mirror and animate again. So you want to animate stuff. I don't mean like, you know, a Garfield cartoon. I mean like, if something changes in your screen, change it with an animation so that it cues the user as to what the heck's even going on. So how do you do that? It's a lot easier than you think. So the now you see why I talked about the timeline stuff before, because you would use timelines, transitions. And when I say transition, there's a whole subfamily of types of transitions in JavaFX that implement that interface. So learn about them. The fade in, fade out, things like that, you can control them. You can also create custom ones. So, wrong mouse? This mouse. Showing and hiding those videos. Remember when I clicked on the box and it came up? It didn't like snap up. There was like a sort of animation. Let's take a look at that real quick. Look at that. That's it. Okay? But and all I'm really doing is taking the scale of the value of the actual media view. The media view is the thing that plays the video. The thing that's here, that's facing you. I'm saying, okay, you're 0. Now get big, and then over the course of 500 milliseconds, scale from 1. Or scale from, take whatever the scale you are in and go all the way to 1. Sorry, in JavaFX, most number systems other than coordinates are from 0 to 1, as in 0.0 to 1.0. Opacity, the true scale, things like that. Now you can have a number bigger than that, and depending on the type of transform or property will sometimes react to it, and sometimes it just kind of caps it at 1. It's not arbitrary, it's all defined in the docs. So look it up in the APIs, okay? So for a scale, I want it to go from 0 to 1. Like 0, you can't see it. 1, it's its normal size. I could make it 2, and then it would be like 200%. I don't need that. Okay? So I just want to, just so you know, I mean, there's some magic numbers in here. I was taught, one of the first things I learned, number 1, when in doubt, comment it out. That was the first thing I learned in high school. To this day, man, that's some badass advice for debugging. But the second one is no magic numbers and no magic letters. Why are there numbers hard-coded in your code? You better have a damn good reason why you coded hard numbers into your code. Why are they not a variable? Especially in this day and age, right? So the reason it's a hard-coded number, I actually get kind of a pass because I don't want it configurable, and 1 is 100%. It's a hard capped number line, as I described, and I only ever want a half a second. That might be the one you might want to configure, maybe. And then down, so whenever somebody clicks on it, this guy's called. And whenever somebody clicks again, this guy's called. And you can see, it basically goes in reverse. Now, if you ever get out of order, you're done screwed, but it doesn't, you're fine. You're like, it'll take you down to almost 0. If you go down to 0, the math gets kind of weird. If you take it down to like 0.01, nobody can see it. It's sub-pixel size, so it's it's effectively rendered invisible.
You're saying you all over the place. Are you allocating memory all over the place?
No. Well, not real. I mean, so what I'm doing is, yeah.
That's the only way to create an object in Java.
So what would be the alternative? You could create
an object. Don't you already have that screen, and you're just shrinking it down? So why are you creating?
I have to create a new timeline object. Now I could create I could have so first of all, I only create one actual object. Notice how I'm not saying like timeline scale up is new timeline. This is a class variable I've allocated one time. All I'm doing is I'm saying whatever was there before.
Oh, those are just properties that are going into the initial.
Yeah. I'm calling a constructor again, and by the way, it's the same thing every time. The reason I don't do this once is because I saw some shenanigans actually last time. I tried to do it where I just created this one time, and then I would play it, but then reset it, and I got into all these little problems of like trying to reset it so that it was exactly the way it was before. I said, screw it, just this works too. And the only catch is, what it's doing is it takes more time. This is not how you would want to do it for like a high performance part of your program, or a server that's got to respond to like thousands of requests simultaneously. You don't want to create new, you don't want to be saying new all over the place. But thankfully, we don't have to, because this is code that's only called from user interaction, which, let's face it, it's only going to happen once in a while. Oh, and if you're interested, this is called, oh yeah, right. It's used by the main application that I embedded, the main demo that I embedded it in. Let's see, math, 3D camera, show video. Ah, right, great. So this is how, because I embedded all that into a single class, and because I made those show video, hide video type thing like that, now I can do stuff like really simple event handling like this. So whenever somebody clicks on, I make a cube object, and whenever somebody clicks on it, call that function. And then, you can do the same thing with like a touch screen. This was, remember, I did this for a touch screen, so I had to make it work on the desktop first, and then all I did was go through and for every mouse event add a touch screen type thing. This is JavaFX, folks. I'm not doing this. I'm just using their API, okay? Well, this is actually pretty freaking easy to debug. I mean, this is maintainable. I wanted 4 cubes, because I found that more than that, it gets a little busy, and the processor can't handle it anyways. Even JavaFX has a limit. So 4 seemed to be the right amount, where you get pretty good performance, and you get a lot of information. Here's where I specify hard-coded sizes, magic numbers, etc. Okay. This is gonna be interesting. If I come back, I'll be doing 3D stuff, and this is how you do. This is how I do 3D keyboard mouse navigation through a 3D scene. I'll cover that some other time. Okay, let's see here. We don't have much left, and how much time do we got? Mm-hmm.
If you're close to wrapping up.
2 slides.
Yeah.
The last slide is JavaFX 3D, and so it's not. I mean, I said again, I can't cover that in an hour. That deserves its own hour, and you've already seen some examples. I think one thing you might want to see is this canvas stuff. I showed you that at the beginning. Remember the points? And I said, I'm going to get to that in about an hour. It's been an hour. The canvas is like a direct draw type mode. Okay, now it's an object, and it has commands that you can issue on it, but it doesn't retain anything. So let's say you have a button, and you want to put that button on the screen. Yeah, it gets rendered. But it also goes on the heap, and it goes into the scene graph as an object, and then anytime something happens in the application, GUI-wise, from an event perspective, there's code that scans through the entire scene graph, identifying every single node, and then checking, okay, does this thing apply to it? Does this apply? Does this apply? That adds up, okay? Now, let's say you want to draw a circle on the screen. They have a circle object. Okay, no problem. Let's say you want to draw 100. No problem. Let's say you want to move those around randomly. The code's not hard. Remember those animation timers? Just call a math ran function and just for each circle just update. But it's got to process each circle independently. And what that means is it's got to go to each circle, find its translation, lay it back on the screen in a different location, and then make sure it fits within its layout, it's abiding by all the layout rules, et cetera, et cetera, et cetera. There's all these things that JavaFX is doing in the background to make your pretty little GUIs work the way that you want them to work. Okay? What happens if you start doing it with 10,000 circles? I'm afraid your web app isn't going to be able to handle it anymore. And even JavaFX starts to get a little cranky. JavaFX will start to get cranky around 25, 30, 40,000 on an i7. Okay? That's in 2D. That is random like circles on the screen. The fastest we've been able to make D3 run in like the latest version of Google Chrome, D3 is a JavaScript library, was like, we got it up to about 10,000 circles, but it choked. It was like, the frame rate was like really bad. It's just not feasible. So how do you get more than that? So I have to deal with data sets that are, I'm getting a call from 1 million. Anybody get a call like that ever?
Dr. Evil.
What's up? Nothing. Well, that's weird. So that just happened. Hey,
Yeah.
Sean Phillips, you won! No, I didn't win. You just hurt my ear. So what happens when you have to do like 100,000? Or hell, even 10,000? And you want to do it really fast, you're going to move these things around. You got to use something called like Canvas in Java. Okay, now if you have like a low-level C++ library, like an OpenGL library or something like that, or Unity, Unity is a different case. I won't go there. But you get what I'm saying. These hardcore gaming engines, what they're actually doing is they're rendering to textures and blasting the texture into the GPU memory so it can be rendered. And so they're essentially drawing straight to memory locations. When I say draw, they're just writing numbers out. So they have all this math that figures out, okay, you want the picture to look like this, well, bada boom, bada bing, we got to get these numbers over here, and here's the transform that makes the number go from your data space to the actual screen coordinates, and the number we're going to write there is like a red and a green and a blue and an alpha value, et cetera, et cetera. These are just integers. Okay? Canvas is the next step up from that really super low level, you got to be insane to want to do it for a living type thing, where you don't have to deal with the memory, but you do have to do the actual raw drawing calls. But in exchange, you get a huge amount of performance. It is fast as hell. So I can render like 1,000,000 points in just 100 milliseconds. And so when I say render it, I mean I could render that. I could just hammer that thing if I want. So it totally depends on your computer. So a desktop machine with an actual a real good video card could probably do it even better. But the point is, 1,000,000 different data points, all circles, I can just go through a list of these points and just do. That's pretty good. And the deal is, you don't get any event handling or event notification or anything, any resizing or any layout. So if you want to do this, you have to handle it all yourself. So yeah, let's see, covered that. Yeah, you don't actually change the pixels. You issue draw commands, which are then added to a queue, and then they're processed as fast as possible, which loosely translates to a sub-millisecond render time. But I mean, if you have a big amount of things that you tell it to do, it could unfortunately take longer than a millisecond. It could take more than 14 milliseconds, and that's bad. Let's look at an example. To look at an example, we're going to go back to wrong mouse. We're going to go back to NetBeans. And then we're going to go back to all the way to where we started, the periapsis map. Look at that. Remember I said I was going to come back to that? This? So this draw map by group, what I'm saying is I have this map of data, and I want to draw it by groups of trajectories. This is an arbitrary thing. It's something that's how we sort our data. We have this type of trajectory and this and this and this. But what it loosely translates to is we have hundreds of thousands of data points at a minimum that have to be drawn. Okay. Go get our sizes of our screen, and then I gotta lay that canvas out, which means I need to actually lay it out, like find the top left corner, bam, put it up there, and then how wide am I? Stretch it out, and then so I'm doing that all myself. Not so hard, but then I've got to go get a reference to the graphics, what they call the graphics context, okay, which essentially is the memory that's being managed by that canvas object. With that object, I can then clear a rectangle. Let me stop reading my code and explain what that even means. I can issue draw commands, and one command is the clear rectangle. What I'm literally doing is saying from 0, 0 to the width and the height that I just figured out, get rid of everything. Because I don't want anything from before. It's like saying, give me a fresh frame to draw on. Then I go into this. What is this? This is crap. What is this? Oh, I know what this is. This is like streams of all my data. So what I'm doing is I'm using the new stream technology, which I'm not going to explain because that's what Stack Overflow is for. But I go through all my different groups of trajectories and I filter out the ones that are not visible. And then for each group that's visible, filter out all the individual trajectories that are not visible. And then for each one of those, filter out all the individual data points that are not visible, and then the resulting collection, only those I render. It's like pruning your data space. There's probably quicker ways to do it, I will admit. But this works. It was my first serious attempt to use the stream library to do, the stream API, I should say, to do like heavy lifting. And it's proven to be quite fast. And I'm able to handle reasonably, we managed to cram 2 million data points into one view once. It only took like a second to render. I'll take that in a heartbeat any day. Anything more, we found anything more than like 500,000 data points on the screen at once, it's just a blur of color anyway. Like it looks like painted mud. Like, there's just too much data. You got to filter it down. Okay, so we've narrowed it down, but let's say we're dealing with the whole fire hose of data. We've got hundreds of thousands of points we got to render. We need to determine what the color is. So I have this map of colors to data point or trajectories. That's kind of nice. That takes just microseconds to do the lookup. And then we get that color, and then we draw. That's that it. It's that easy. I'm going to get to this in a second. So let's look at this here. I've got some options to let you have just a circle for the point, or if you feel froggy, you can draw, instead of a circle, a line at that point, which is drawn in the direction of an arbitrary set of variables. In this, typically the velocity direction. It's very useful. So let's say you know where you are. The state vector for a point in space in time is composed of at least 7 variables. Okay, your x, y, z coordinate position, the time at which you're at, and your x, y, and z velocity. Now there's actually dozens of other relevant variables, but to know exactly where you are, you need those things. You need the coordinates, but you also need to know where are you going and how fast are you hauling ass in that direction. Otherwise, what's the point of knowing where you are? Okay, so we can set it up so that the so that the direction of the arrow is pointed in the velocity direction. So in other words, I may be here, but I might be pointing that way, or I might be pointing that way, and that's very useful for the analyst to determine. Okay, this is the point that we want to do the maneuver. Right. So let's say you've got 3D space. See, this is if you know a 3D programmer when you see one, because they'll hold up their hands like a gun. These are the axes, and they'll be staring at it like doing this. They're crazy, but that's actually relevant. So let's say y, x, z. Okay. Planet. Right now, we're here, right? Let's say you're traveling in a nice, easy circle. That's what it's going to look like. But nobody does that. You gotta have something crazy, Like you're going up and then down. Oh man. Like let's say that's where you actually are at that moment. But let's say that here, just a few dozen time slots, aka state vectors, in the past, you're like this. And let's say you need to get into a trajectory that takes you out in that direction. Wouldn't it be better if you made the maneuver here, because you're pointing in the right direction, so you can use the velocity in your favor, versus down here, where you're pointing in perpendicular direction, and now you're fighting your own velocity. That is the battle of orbital mechanics. Okay. That's why we want to do that. So that's all I'm doing here. I try to sprinkle in some of the stuff I've learned in the last few years, the space stuff, because I didn't come from like a NASA background. I came from mostly like DoD, but some manufacturing stuff. So I had to learn it as I went. So anyways, we're checking to see like what's the format, and then if it's a line, we use the same. We have to set this what's called the stroke. So when you draw something, no, Mike just gave me something. Don't lick the screen. So like when you draw something here, okay, look how fat my fingers. I have sausage fingers. Look, so the outside of this is the stroke. Okay, the outline, the ridge of when you render something. This is true in JavaFX, whether it's a canvas draw command or if it's like a button. The stroke of the border of the button is the outline. Okay. The fill is the color that's in between. So the color of my sausage finger is like this like sickly white hue that doesn't get enough sun. It's like a peach pink. And then you can also color the stroke differently. Okay? Remember that. That's actually that has burned me so many times where I've set the stroke and forgot to set the fill, and it doesn't come out the way I want for whatever reason. But in Canvas, if you want to draw a line, you really got to draw. You got to set the stroke of the draw command, and then you do what's called stroke line. Okay. And if you want to do a circle or some other filled area, and there's only a few options, you've got to set the color to the fill, and then do a fill call. So let's look at those real quick. These are your options. Okay. Now I wanted you to look at these. You know, you can draw text, stuff. Okay. I mean, obviously they give you those convenience methods that are line and oval. If you're going to leave, remember this. This polyline, okay, and polygon. These are your friends. Okay, because yeah, rectangles and text and lines, those are your basics, right? And it works for a lot of things. But if you want to do something really fancy, like a connected thing, you determine what your points are ahead of time, get them in order, and then say, blast them all at once. And why do you do that? Because if you try to draw each line point to point to point, it's issuing separate commands that are then put into this queue, and it has to draw it, step back, pull something off the heap, look at it, oh, line, draw it, step back. That takes time. Microseconds all add up, right? With this, it's smart enough to say, I'm just going to hammer through them. Okay? And then the fill stuff, same thing, but it just slightly, this is automatically filling in the regions, okay? So thanks for stopping by, I appreciate it. I know you guys are going to start leaving now, so this you're like, finally, we can get out of here. This is pretty much the end of the line that I had intended to show, and I can what can I do? I mean, I can go a little bit more into the JavaFX 3D, but you guys have already seen what I wanted to show you. The only thing I really wanted to show you after this was just the one example that I had of the JavaFX 3D stuff that you hadn't already seen, which is, yeah. So I've already said these things. Okay. I think I closed the application, so I'll start it back up again. Great. So I created this thing. It's a tool, and it is a 3D data, multivariate 3D data viewer. And what it does is you take those periapsis maps, right? And instead of rendering all the data points in like coordinate space, you render it in 3D, and then it allows the user to, I don't know, pick this one, screw it, to change the variables on the fly. It takes a little longer to load though. Oh, this is not good. Oh, there it is. Okay, so remember that 2D view I showed you earlier? It was like flat and looked like a Fabergé egg. But this is what it looks like in actual 3D space. Okay, and you're probably thinking, yeah, okay, that's nice, Sean, but like, so what? Okay. Well, the so what starts getting interesting. When you can start changing which coordinates are being rendered. So instead of the y position, we'll put the x velocity value on that side. Okay. And then actually, let's be smart about this. We're looking at it in the position space. So we'll there it is. So we just flattened it. So let's do it again. Hold on, bear with me. It's hard for me to do it at this angle. So this is the y-axis, so we'll do the y velocity. Right. Kind of neat, right? It's like computer art, right? And then we'll look at, it's on a position. Oh, right. You can't get to the bottom, right? Because of the, am I on the edge? There you go. Let's look at the z velocity over here. Okay. So this is the same data, but replotted in 3D so that you see the velocity directions. And I can't quite get to the, come on, let go. I can't quite get to the bottom because of the, because I have it optimized for 1080p, unfortunately. So I can't change the third parameter, but I think you get the point. It would change yet again. And what you'd get is this weird diamond type shape. So now you're looking at the problem in the velocity directions, okay? And then you can start playing little games like, well, maybe I want to look at it in the Y position and the X position like I normally would, which is a 2D view that they're accustomed to. But then I want to see the Z velocity. Well, you know what this tells me? I don't got to be a trajectory design guy to know that the Z velocities of the trajectories that are in the purple and blue families go crazy. They're hugely out of character with the rest of the data. And if they're split evenly from the top at the top or the bottom. And then I can look at this now and I can say why and how much. So as now this is a new view that only a couple of our trajectory people have even had a chance to see, so they're still trying to wrap their head around what they could do with it. But the first thing they can do is they can say, well, oh, okay, so then I need to know what that trajectory is, and I want to know what its inclination is, because it might be a candidate that I want. And then you can use those range sliders that I showed you earlier, that filter data. It does the same thing. I can go to all the trouble to show you, but it filters this data down. So in other words, now you're not only able to look at a problem. Oh, it looks way nicer over there. I keep forgetting that. Now you instead of looking at the problem only in 2D and trying to work within that constraint, you can now look at the problem any way you want, as long as you know what to look for. But you see how that doesn't work right out of the gate? You can't just start with these amazing tools, the data visualization tools, because if you don't know what you're looking for, what good is it? Like, I don't know if you need inclination versus eccentricity versus semi-major axis as a chief driving parameter towards your science goals. I don't know that as a developer, so I made the tools so that they're adjustable. And even as a trajectory designer, you may not know off the top of your head what you want. You may only know that, hey, I need to get like within this much altitude because we know that the geysers at Enceladus are the bulk of the material that gets ejected. The ice-water mix is between 50 to 150 kilometers off the surface. That's really close. Really, really close to the surface. Like danger, like you would never, ever send a spacecraft that close normally, unless you intended to land or impact. We also know that there are some particulates based on our measurements, our sensor readings from the ISS, that do eject as high as 500 kilometers. But unfortunately, it's quite a drop-off, and so all I know is there's altitudes that are better than others, but you got to be realistic. You can't only get so close without crashing this damn thing. So there are going to be a number of solutions of potential trajectories in a mass of data like this. And remember, this is just one slice of data. This slice of data is measured by the energy level. So if you speed up or slow down, these things literally change dramatically. They reform, and you got to look at it all over again. So somebody may say, if we can get to this energy level right here, I have the following 3 trajectories that get us under 300 kilometers and don't crash us. Or if we speed up if we increase our energy and speed up the spacecraft in terms of velocity, I can get us even closer, but there's only one trajectory that does it, and it takes us like way out, and then there's this hang time forever, and it's not ideal because you may only get like a single pass every once a week or something like that. You see the problem? There's just so many combinations. So a tool like this is meant not to give you the answer, but to help the human be the expert and sort through the mess of data as quick as possible. And I hope that the people, I'm sure nobody here does trajectory design. I don't do trajectory design. I just write the software. But I know you all have to do some sort of data analysis as part of your work, right? So I hope you can see that at the end of this, tools like this and some of these other tools, with a few exceptions, really are just data analysis tools.
Have you ever seen MATLAB? We're using a lot of MATLAB.
Oh, our analysts, that's all they use, and it's a scourge of my existence because MATLAB's great.
But it cannot handle this type of work.
That's what they all prototype their algorithms and equations in. And then when they go to do an actual interactive tool, it takes 2 hours to generate the data. It takes minutes to render something on screen. You know what I mean? And so what they do is they make the compromise of, okay, I want these algorithms and I want all these computations, but I really want it in MATLAB, so I'm going to downgrade the data density, meaning make it sparser, and I'm going to make it not interactive and not flexible, and I'm only going to render small portions of it at a time. Great, they should be doing that. That's what it's for. But the reality is they're spending just as much time trying to load data in and out and keep track of what they did see and what they might have found as they do coding it up. And then, okay, you found something that might look interesting, but you lose all context if you've got to sit there and reload other data and plot it, and then maybe save an image, and then you look at images. The point of this tool was to capture all that, but in one cohesive, it's barely cohesive, one tool where it's literally side by side, or you're in the data. In other words, I got to say this. We wanted the data to be the interface. Okay, that's important. MATLAB is the interface with MATLAB. The data is the interface with this particular tool, and that's the way you should be designing your tools beyond your cookie cutter type spreadsheet type stuff. And there's always a need for some tool that's just one or two buttons and you go, right? But if you're going to make a tool that helps people make real decisions on data, the data should be how they interact with it. And the things that I've shown you are what I've learned over the last 3-4 years in order to do that. And I say JavaFX is fantastic for that. Anybody else?
I had a couple questions about various things, and we can start maybe with the canvas. So you said the canvas doesn't have any event handling beyond just the canvas object itself, the container.
Right, essentially, yeah.
And you do a really fast handle of, when you mouse over points, it picks it up, and
so how's that work?
Well, yeah. What are you doing to do that reverse lookup, essentially, to translate the string coordinates to the data coordinates?
I'll show you that. So what he's talking about is something like this. So this is the same map. We're going to put it in 2D. Yeah, right? And then let's see, point selection. So this targeting reticule. These are just lines of your high-level 2D line objects. These are not canvas lines. And whenever the mouse moves, I change its start and end points to always be at the what's it? And then when I get closer, oh, okay, what happened? So what's happening is every time the mouse moves, I have a custom event handler that I attach to the mouse in this class that essentially literally every time you nudge that mouse, looks at the X and Y coordinates of the mouse and then says, okay, are there any data points in the data set nearby? Now, how does it know how to do that is the tricky part. Math. But it's not bad. You're essentially doing a coordinate transformation from the screen coordinates, which are 0, 0 to 720p, to the data space, which is, I think it's like in this particular file, I want to say -1 to 1. Okay? So completely different number lines. So what does that look like? And how the hell are we able to do it so it jumps around? See how it's jumping to the nearest point? Yeah, that was the whole idea. Because it occurred to me that, yeah, I could give them like a crosshair where they just click, but how do they know they're even on the one they want to click on with this many data points? So, it really becomes evident down in here. See how it's like, now we're close to that. Now we're close to that one. Okay? It's just like a helpful thing. These are the types of things you're doing, and here's how we achieve that. can't give away all the secrets, but I can do some stuff. I'm glad you asked. It's right there. So, based on a box, where I define the box to be the XY coordinate here and the XY coordinate here, I then go and grab the data in that box. Okay? And then what I do is I search through that box and I just find the nearest one. Now, why don't I just search through all the data points and find the nearest one? Well, does anybody want to take a shot at that? This is like a math comp sci type question.
Take a long time to look through all the dots.
Well, exactly.
You'd have to sort them.
We do that anyways. We sort. Yeah, it takes a long time because remember I said we're dealing with hundreds of thousands, if not a million points. So if I'm trying to find the closest point, you do it's the line algorithm, right? You're essentially doing you're doing there's yeah I forget the name even. I looked it up once. I was like, oh, that's what it is, and then that was it. But that's important because I can't do that for every single point, because what if the point I'm looking for is at the end? I just did that huge formula a million times. Crusher. Can't do that. You can sort the points, but you got to figure out where you are in that box. Okay. So what I actually do in order to
How do you know how big the box? Oh, because you don't lighten up any of the dots until it's within that box. Yeah.
Right. And how do I know where to set the size of the box? Wherever the current XY position of the mouse is, I just add a few pixels on either side.
Right.
That's it.
And there you widen the box.
I'm sorry?
He doesn't want
No,
he
he
doesn't
So you don't find the points and then you
You
widen.
just have to move the mouse.
Oh, okay.
Yeah.
Fixed size.
It's a fixed size. And then and that was important because we found that with sparse data sets, you want a bigger box because you want to snap to the nearest point quicker. But with like the big muddy data sets that are like it's like so thick, you don't want to be searching through a huge box of points. But why a box? Okay, the box is because you're dealing with two axes. And now we're starting to get into like comp sci tricks. Tricks. It was cool when I was in school. You take the number axes and you sort all the data. You keep two separate indexes of the points, sorted lists, if you will. One in the x and one in the y. And then that now all you have to do is do what's called a coordinate transformation between the pixel number line and your data number line, and that gives you the exact index in those sorted lists of where the range of points are. At that point, you just grab the two chunks and you've got your potential points, which now went from here down to this. And then you can now, instead of doing like 100,000 or 500,000, you've got like 50 or less even. And then use your Pythagorean's theorem on each one of those. And you just find the closest one. I am sure there's ways to optimize this, but it works, This is the code that gets that box, and I mean, you look at this and you're like, oh my god, what is this? But if you look closely, what I'm doing is I'm getting the sorted lists, and then each time, one axis at a time, doing a binary search out of the box from Java. That's a Java thing. That's not me. Okay? And I'm searching for the periapsis as I've defined on the fly based on the x position. Now this is Java 8 right here. I'm specifying a comparator that looks periapsis. Yeah, periapsis is the name of the data point itself. That's what its type is, and we have a custom class for that. So this is just a standard comparator. This is like Java 6 actually, technically. And all I'm doing is saying if you had two periapsis points, how would you know whether one is greater than or less than the other? Thank you.
Thank you.
That's how you do it, and then for graphics' sake, you do it one at a time. So now, once you have these types of comparisons as objects, you can pass them in. Oh boy, here we go. Where'd my start Ah. Once you have these comparator objects, you can pass them into a binary search call, and the binary search algorithm and implementation is just about the fastest thing you could get in Java. I mean, it's fast. And people way smarter than like all of us combined wrote this stuff and have tested it for years. And it can go through millions of data points within, microseconds. Okay? As long as you pre-order your stuff and define these comparison objects. Which, by the way, when you go to sort your data points, it becomes collections.sort or like list.sort, and you pass to it the comparator object. This stuff all ties together. This is not JavaFX. This is just Java. Okay? So essentially what I'm doing here is I'm saying I'm gonna search for along the x-axis for the top and the bottom, and then do it again for the y-axis for the top and the bottom. That gives me my box. But what returns to me is the actual number in the collection line where it should be. So now it's just an index lookup. I'm not like searching. I'm just saying give me the one after this because I know that's the boundary. Now I've got a list of trajectories or a list of periapsis points that I know are within this box, and then I can search through those. Keep talking.
Your points are already sorted, or you're sorting them in this algorithm?
I pre-sort my points. So when I read them in from the file, they tend to be in files. They're just string data, like CSV type stuff. But there's like 20 megabytes of them. And so every time I read them, I say, okay, you're going to go into this one, you're going to go into this one. And I order those, I add them to these lists of points. And then once they're all loaded, I say, okay, now sort this list based on the X position. So that I can do this so quickly. So I'm doing, the moment you drag and then drop it, it reads them in, adds them to the list, and then when it's all done, the last thing it does before it renders is it says, okay, now everybody sort. Are we done? Good. Render. And then bam, you're off to the races. Now, from that point forward, it's already sorted. You only have to sort it once. So the sort, that can take milliseconds, but we're talking like single-digit milliseconds. And there's really probably no expectation that like a 20 megabyte data file be rendered instantaneously by anybody. I mean, come on. And you saw how fast it renders. It's just a few moments, and boom, it's up. The thing that really is important here is the transformation itself. Here's an example. This is not a good example. Let me do this from here. Transfer X to screen. Ignore this else branch. This is for a specific case. You want to look at this if return here. So given an X coordinate in data space, how do I render it to the screen? It's this formula. Okay? And I'm not a math genius, but what you're essentially doing is, given the width of your number line and giving the total range, the minimum and the total range of what it could be, you're essentially finding that ratio and applying the ratio of how to move it on the screen. So in other words, if I have a point in my data space, and remember I do it from -1 to 1, and it's like negative 0.5 by positive 0.5, then those numbers are going to go into these formulas, and it's going to say, okay, what was the smallest amount? What's the total width? And then, oh, well, that's going to go about here, and it's pretty really close. So every single time we have to draw that 2D thing, this calculation has to be done for both the X and the Y coordinates of every single point. And now, trust me, when I say with the last one, there was over 100,000 data points. That's pretty fast when you think about it. Optimizations, we could pre-compute these based on the screen size. When you play like a video game that's not like a cheesy web app or something, but something that's like a real actual video game that like takes over your video of your computer, it goes black, and then there's some thinking going on, and then it has like this rendering mode that you're in. What it's doing is it's figuring out like what its limits are. And you know how if you try to change the resolution of your computer, like you try to if you mess around with your video settings at the OS level, it can really dork up your video game. And some games handle it better than others, but That's because they're going through and they're calculating a whole bunch of stuff ahead of time. Now, for the 3D games, it's all about textures nowadays, and so the GPU handles that on the fly. So it's less true than it used to be. But one optimization here could be, oh, your screen coordinates are currently X. I'm going to, for every single point, compute this once. Then, if somebody changes the data on screen, I just, instead of doing this calculation on every single point, you just say, give me the current value, give me the current value. The catch is now you've shifted. Yes, you've saved time in your render loop, but now you've put a lot more strain on your upfront application management logic to be aware of, hey, my screen's changed or my layout changed, and make sure that these things get called. Totally doable, wasn't necessary. So if somebody came to me and said, 500,000 points is great, I want 10 million points. Okay, well then I'd probably do something like this. And then I would have a longer load time to load a status bar or something, it's pre-computed.
The other question I had was, you got that spinner when it's busy.
Yeah.
It's all show. What are you using for that? Is that just another pane that you're...
Yeah, it's a custom node.
Okay.
And what I did was I made a VBox. Yeah, thanks a lot. Well, here's that thing. It's great. Oh, well, it's going to take me longer to pull it up. It's a VBox. It's a progress indicator, which is a component that comes from JavaFX. And I threw a label in there, which is a component from JavaFX. And I laid them out on the screen. I then made a class, which extends VBox. Look, I'm using the latest version. I haven't even checked my code in yet. Look at that. Oh, here, look at that. I made some changes today. That's weird. Let me see that. Okay. I even had progress bar, but I didn't really use it that much. And then I've got this opacity where I set the opacity to be, I want you to be able to see through it. And then essentially what I do is when you don't want to use it anymore, I just tell you to fade it out. So that's like a public API type thing where the main application can say, okay, I'm done with you, and it just fades out real quick. So
in all your other classes, when you are doing a computationally expensive action and you say it's set busy is true, are you using bindings for this, or are you just saying that you basically telling your application that, okay, just show this, turn this visible, and it's just sort of always spinning in the background?
in this case, it's that. It just is. It just if it's not on the screen, it just doesn't matter. It doesn't affect the performance at all. So it makes more sense from a use case to be able to turn this on and off with like a button, if you will, versus allowing things to bind to it. Because then, what do I bind it to? It's something.
I was trying to figure out the binding.
Yeah.
Like how you would do it with binding.
And this is a case where it makes more sense to have a more traditional public type API. You have a question?
Yes, I do, but it's about Snapshot now.
Oh, go ahead.
Does Snapshot capture the pixels of whatever is in an FX window?
Well, no. You specify the node that you want to have the picture taken of, whatever that is. So if you have a border pane with everything inside of it, and you say, give me a snapshot of the border pane, then it'll give you a screenshot of the whole screen.
So if I wanted to use, are you familiar with MPlayer?
I've heard of it.
Okay, well it has the capability to hijack X windows, like a JavaFX window.
Oh, okay.
And you could use JavaFX to have a transparent pane and add overlays to a video. So I was wondering if you could use Snapshot while rendering your video off the screen, but the rendering's all done with MPlayer, it just happens to be on a JavaFX pane. I don't know if Snapshot would be able to capture all the pixels, and then I'd be able to put those pixels on a, something that people can see, but then add my overlays directly onto the video without using a transparent window that's on top of the video.
You have a lot of buts in there, which is it was hard for me to track, but on the surface, I see no reason why you couldn't do that. If you have a JavaFX node and it shows things on screen, Snapshot should work. Now, when I say node, I mean like the Node class. There's a class called Node.
Okay.
Okay, and that supports like snapshots. I am not an expert at snapshot. Okay, so and what you're talking about almost sounds like you're routing some rendering from some other.
Yes, onto JavaFX, but I needed to add overlays to the video, and FX had the transparent capability.
I mean, how do you think they're overlaying it into JavaFX? They're probably doing an image capture on the fly and sending the image data over a buffered socket to some sort of something that's then receiving it and it's just putting it over top. You're essentially saying, I'm going to do it to you. It just
I didn't know that would hurt performance, but it seemed like you could play video just fine. What you did.
Well, I mean, I have technically 8 videos playing simultaneously in that CubeSat media thing, plus animating. So I mean, I tried to add like 6 or 7 and it started to really bog down like too much. So 4 was like the sweet spot, but 4 cubes, but there were 8 videos, 4 playing off screen and using snapshot, and then the other 4 were the ones that were playing that would be raised or lowered based on the clicks. What you described sounds completely doable from a performance standpoint. What I'd be wondering is whatever mechanism is being used by MPlayer to jack something into the JavaFX object itself, how is that actually being done? Like if they're doing some shenanigans really low level, like
I think they're just hijacking the X events itself. And like when you can't use that window at all once MPlayer's taking it over.
okay.
The FX window, if you try and render something on top of it, they will flash like they're fighting each other.
Yeah, right. Because you have 2 different rendering loops trying to update each other.
Right.
Yeah. Probably anytime it changes, MPlayer then updates something or whatever. We don't have time to talk about it because I do have to get going, but and you guys have been here for a long time. But I would love to hear about it. So if there's some way you can like, I'll give him my email address.
Yeah, if you have a business card or something.
I don't.
Oh.
I'm sorry.
That's okay. Well, I can. If it's okay, I'll give you your email.
Oh yeah, of course. I'll give him my Gmail and then it doesn't matter. Hey, if you guys need a job.
Quite a few openings.
Yeah, and it's to the point now where they're starting to offer like bonuses to employees who find people for certain contracts. I will split it with you. It's $1,000 a head for anybody who gets hired at Dahlgren. I will split 50-50 with whoever manages to get me either a hire or somebody who somebody who wants to join on themselves. This isn't sorting along city, unfortunately, but we have like 6 openings, but they're all like electrical and like QA and whatnot. See, so they're not software unless you want to be chief of staff. But we do have software developers. Lanham is our facility just outside Goddard. That's when I work at. That's our headquarters. And so I know we have a couple of software positions there. This one right here, you'd be working directly with me on the James Webb Space Telescope. So that's a pretty nice one to be working on. All current scheduling aside, that you two. Okay?
Coming.
We also have web development.
Thanks for sticking around.
Bye now. I think we lost everybody. You don't have to clap. There's only like 2 people left in the room.
Stop the streaming.